Assalamu alaikum to lecture number 16 of Software Requirements Engineering, CSCE305. And in today's lecture, we are going to continue with our topic from the previous lecture, that is elaboration process or analysis during the requirement engineering process. And just a quick recap what we started talking about in our previous lecture. As you guys remember, software requirements engineering has 7 distinct processes, and we have covered inception, elicitation, and we are talking about elaboration these days. And within elaboration, we said when we want to analyze or elaborate requirements, there are 2 main approaches of doing it. The first approach that we discussed was object-oriented approach, and we said that there are multiple kind of modeling we can do within object-oriented, and those included scenario-based modeling, class modeling, and behavioral modeling. And then there is another approach of analyzing requirements or elaborating on the requirements that you have elicited, and that approach is structured approach or the structured analysis. And within the structured approach, there is one main kind of modeling that we do, and that is flow-oriented modeling. And within this flow-oriented modeling, there are multiple diagrams or there are multiple tools that can be used to analyze requirements. In our previous lecture, we started talking about one of the diagrams within this flow-oriented modeling, and that was data flow diagram, or we call them DFDs. Now, as the name suggests, that we are saying this is flow-oriented modeling, so we know that we will be talking about some sort of flow, but what kind of flow? So when we talk about these data flow diagrams, we are actually interested in understanding what is the flow of data through the system that I'm going to make. So we know as a requirement analyst and as software engineers, as requirement engineers, that there are certain inputs being sent to the system, and when a user sends those inputs or gives those inputs to the system, he expects something back in response, and that is the output. So we know that if this is my system, then there is an input, the user would expect an output. And this is what I'm interested in when I'm analyzing my system through this structured approach, or when I'm doing this flow-oriented modeling. So what I'm trying to model is the inputs to my system and how my system is going to behave and what kind of outputs the system is going to produce. So I am interested in flow of data. So the first diagram that we started looking at was DFDs, as I just said, and there were a few interesting things that we talked about DFDs. There are lots of rules involved in making DFDs, and it is important that we follow them. There are lots of things. For example, we said that there are multiple levels of a DFD. So we talked about levels of DFDs. We also talked about some of the rules concerning DFDs. For example, the numbering convention. Then we talked about balancing. Then we talk about naming rules as well. And these naming rules, they are basically for different kind of entities or different kind of concepts which are there in a data flow diagram. So let's quickly revise these things, and then we'll move to the example that we were discussing in our last lecture of the safe home security product. So we said that within a DFD, we know that there is data that is being flown to the system. So how do we represent this flow of data? That is normally represented by this straight line with an arrowhead, and this actually shows the direction of the flow. And we also said that this data is processed by a process. So some kind of transformation would be applied on this input data to produce the output, and that transformation is applied in a process or in a function, and a process is represented by an oval or this round circular shape. So this is a process, and this represents the data flow. Then there are a couple of other things which we make when we are making a DFD, and one of them is the external entity. Now, what is the external entity? We said that this is very similar to the actors that we identify in when we are doing scenario-based modeling or when we are making use cases. And we say that anything that is outside the scope of the system or outside the boundary of the system, whether it's a person, whether it's a machine, or it's another system, that's an actor. And it is very similar in DFDs that all the other things which are outside the boundary, but they are sending some input to the system and they are expecting some kind of output from the system, they are all external entities. Why it is important to identify these external entities? Because as we said, we want to know who is sending the input to my system and who is expecting something back from the system. Now, if that is what we want to know, we need to identify those entities, that who is responsible for sending this information, and what does that person, that machine, or that another system wants back in response. So all those things, these are called external entities, and external entities are normally represented by these rectangles. So this actually shows an external entity. So this is an external entity. Then we also talked about that there is another element or another concept that we can draw when we are making DFDs, and these are called data stores, because we are talking about data. So we at times when we are making an information system, we need to store something somewhere, and we know that databases are used for it, but in this logical representation of the system, we need a mechanism to actually show where would my data reside. So for example, as an output, an external entity wants certain kind of report, and this report has to be generated by combining lots of different kind of data. And so where does that data come from? Because processes are going to do some transformations on the data, and they will put it somewhere, and when the output needs to be generated, another process would go and pick some data from the data store and process it in a certain fashion and produce the desired output. So normally these symbols with a D written here, they actually show that these are data stores. Now, as far as the naming or labeling of these concepts is concerned, we said that there are certain rules when we want to name them. For example, these data flows, they need to be noun or noun clauses, because we don't want any verbs here. That is important. But whereas when we want to label a process, then we want verbs or action words here, because here some action is being taken on the data that was input to this particular process. And as far as external entities are concerned, they are again noun and noun clauses, and data stores, they again can be any one of these things. So naming is very important when we are making a data flow diagram. Then there was another concept which was related to levels of a DFD. So let's quickly revise what are the levels of a DFD. So we said that there are certain levels in a DFD, and we talked about that whenever we are making a DFD, we start with a very high level of abstraction, and that high level of abstraction means that we think of our system as one big process, and we try to identify all the external entities who are interacting with my system, and that is normally called a context DFD, or it is also referred as level 0 DFD. So what do we have in a level 0 DFD? We would have some external entities who will be sending some input to the system, and there would be some external entities who would be expecting some output from the system. So we have this external entity E1, E2, and maybe there is another external entity who are expecting some output from the system. So, something like it, and here we say this is my system, which is again a process. Now this is a level 0 DFD. Because in a level 0 DFD, we only have one process, that is our system. We do not need to number our processes. Okay, but this can become very complex, because as a system analyst, what I am interested in knowing is that how these inputs, or how this input is transformed into these outputs, what kind of actions are taken on this input to produce these multiple outputs. So what do I do is that this is the boundary of my system, and these are the inputs to the system. So let's say this is another input to my system. So these two are the inputs, and these two are the outputs. So I want to know what my system would do to these inputs. So what I'm going to do, I'm going to decompose this one process into smaller processes, and this is something we talked about, that we decompose our processes. So what we are going to do is that this was my system boundary. So what I'm saying is I'm going to decompose that into smaller processes, because I want to know how this input is transformed into these smaller processes. So, and again, I have some entities, the same entities, and this is sending input to this process, this is sending input to this process. They are doing something here, here, and here, and I don't know, here, and they are producing these outputs. So what I've done here is very simply, what I've done is that I have decomposed this main system into these 5 processes. So now instead of one process, I have 5 processes, and I have lots of these data flows, because these 2 data flows represented the main inputs, which were already there in a level 0 DFD, and these 2 data flows which were representing outputs in a level 0, they are also there. So But there are lots more data flows that I have identified, because I have identified more processes, and when these processes are there, they're going to talk to each other in some fashion. So these are all data flows. So this is a data flow. So we have identified more data flows. And again, when we have to label all of them. And when we're labeling them, we need to think about that all these labels, they should be noun or noun clauses, and all these processes, they should be verbs. But now, because we have so many processes, we would like to number them. And again, numbering does not mean, this is something which I emphasized in the last lecture as well, that numbering a DFD does not mean, or it does not signify the order of execution. For example, I would number this 1, I would number this 2, 3, 4, and 5. Now, it may happen that the 4th and 5th process, they are executed first, and then the 1, 2, and 3 are executed. So the numbering is not important. They are just there to identify or distinguish between these different processes. So we have these 5 processes now, and as I said, this is my level 1 DFD. Okay. Now, and there were a couple of other rules, and I said there is rule of numbering, there is rule of naming, and then there is a rule which we would call balancing. Now, a DFD should always be balanced, and we worry about this balancing problem occurs only when we decompose a DFD from a level to the next lower level, or a lower level of abstraction. For example, this was my level 0 DFD, and this was the boundary of the system. How do I check whether my DFD is balanced or not? I go to the previous level. For example, this is the process I have decomposed. I look at the inputs and the outputs from this process. So I have there 2 inputs and 2 outputs. I go to the decomposition of this process, and this is how this process is decomposed, and this is the boundary. Now I would look outside the boundary of the system, and again there are 2 inputs and there are 2 outputs. So I would say, okay, that this is a balanced DFD, because the number of inputs that were there in a higher level, they are same in this lower level, and same is the case with the number of outputs. Now another thing is that we talked about that how and when do you know that when should you stop decomposing a process, and there is a certain convention that it's a general rule of thumb, but it's not always applied. At times you decompose a process even if that is not the case. So the general rule was that if there are 8 or more inputs and outputs coming from a process, then we decompose it, because this would actually signify that this process is too complex because it's doing too many things. But normally at times what happens is that even if a process has lesser number of inputs and lesser outputs, you still decompose it, because it's kind of a complex process and you want to know what's happening inside it. So this is the level 1, and again when we are going to level 2, numbering is very important in that as well. So, and what would happen when we draw a level 2 DFD? So you do not need to draw the complete DFD when you are drawing level 2. So for example, and remember that these levels are to understand or increase your understanding of a certain process. We drew level 1 DFD because we wanted to understand our main process. Now let's say that this process number 4 is very complex, and we want to know how this process 4 is transforming this input into these 2 outputs. This is what you want to know. So we are going to decompose our process number 4, and what we are going to do here is that let's say we say, okay, this 4 can be decomposed into 3 sub-processes. And how would I number them? Because these are sub-processes of process number 4, so I would number them in a fashion that I can actually relate, I can know that who is the parent of this sub-process. So I would number them 4.1, 4.2, and 4.3. Now these numbering scheme would actually tell me that these sub-processes, they belong to process number 4, but these are sub-processes of that process. And again, remember that we need to be careful, that we need to ensure that this level 2 DFD is balanced. So for example, what were the number of inputs in level 4 to this process number 4? There was 1 input and there were 2 outputs. So whenever we draw this DFD, we need to ensure that the inputs and outputs are the same. So which is kind of what we have done here, is that there is 1 input that is going into this boundary, and there are 2 outputs which are coming out from this boundary. So this is what balancing is about, and this is how we number DFDs. And there's another interesting thing we talked about DFDs, and that was that level 1 is the only DFD where we can possibly draw all the elements or all the concepts that are there in a DFD. For example, we can have external entities, we can have process, we can have data flows, we can have data stores. And something very important about data stores, that you only draw a data store in a DFD when it is required by a process. So for example, this process 4, it required a data store. We do not need to draw that data store in this level 1 DFD, because it is not, we have not actually decomposed process 4 here, but we can draw this data store here. So it might be that, you know, this process is storing something here as well, which, you know, later on they are accessing as well to do something. So it is important that if a data store is local to a process, you only draw it when that process is decomposed. And how many DFDs would be made when we are making a level 2 DFD? For example, in this particular case, we have 5 processes at level 1. So if we decompose all of these 5 processes, then there would be 5 level 2 DFDs. So level is determined by this numbering scheme. So when we number a process 4.1, then when we automatically know, okay, this must be a process in a level 2 DFD of process number 4. So this is a level 2 DFD. And again, as I said, when do we stop decomposing a process? There is actually no hard and fast rule about it. It depends on the complexity of the problem at hand. You look at a process, if you think that you do not understand and you're not able to analyze this properly, you decompose it further. And remember what we talked about in all these analysis lectures, that, you know, these were some general things about DFD that I wanted to mention, because people often tend to forget these things. That when we are doing analysis, there are 3 things we are interested in. Number 1 was, we want to know more about the information domain. We want to know more about the behavior of the system, and we want to know more about the functions of the system. Now this, within this structured analysis, this DFD modeling, it has it all in it, right? It is telling us about the functions of the system by identifying all these processes, and by knowing the transformation that are applied on the data, we know the behavior of the system as well, because we know that, okay, when this data is supplied or when a user sends this input, how my system is going to behave, and what functions are applied on the data so that the system behaves in a manner which is desired by the end user. And as we talked about in our last lecture, that this is the logical representation of the system. And when we draw these DFDs, we take it back to the client, we share it with them, and we tell them, okay, this is my, or as an analyst, we tell the client that this is my understanding of your system, and this is how I believe that this is what I believe, these are the functionalities that you want, or this is kind of behavior that you want from the system, and these are the inputs that you said you're going to send to the system. So it's a very interesting and a very useful approach when we are analyzing a system. And so again, in today's lecture, we will continue with our discussion on flow-oriented modeling, and we looked at the data flow diagram, we looked at the basics of DFDs in our last lecture, and we started looking at the example. So what we do today, we will continue with that example, and we are also going to look at another diagram that can be made in flow-oriented modeling, which is called context flow diagram. And then there is another tool which can be used, which are called processing narratives. So which is kind of similar to the grammatical parts that we used to do, which we have already talked about in object-oriented approach, and to some extent in the structured approach as well. So this was the example that we were doing in our last lecture, and we said that this is a context DFD, or this is a level 0 DFD of the SafeHome software. And just to give you guys a quick recap on what this system was about, although we have been doing it for 3 lectures now, that and once again, this example is taken from the book by Roger Pressman. It's so you guys can actually go in there and read it, where it is the example is explained more properly, I guess. So what is this software about? So this is a software where there is a control panel involved, and a user can set the alarm. He can set his password. He can change the configuration settings. He can do all these things with this particular product. And what this product does, it is also connected to certain sensor, to certain alarms, and telephone lines. So depending on the input of the sensors, an alarm might be triggered, and a telephone line might be triggered. So an event might be sent to a telephone line, or it can be sent to alarm at the same time as well. So through this description, we made this particular DFD, which was a level 0 DFD. So we identified what are the external entities. So now remember the definition of external entity that we have talked about. It's anything and everything which is outside the system boundary, we say that is an external entity. So to this safe home function, or to this safe home product, what are the external entities? We have said that there is this control panel. So that is our one external entity, this control panel. Then another external entity is, or are the sensors which are deployed, and they are also connected to my product, and because they are sending certain inputs to my product. So there are two sources of input to this particular system, and these external entities are control panel and sensors. Where control panels, through a control panel, a user is sending his commands and certain data, whereas through the sensor data is the input to the system. And then there are certain outputs from my system. One output is the display information, which I am sending to the control panel display, and this is for the user. Then there are two other outputs. As I said, that there is an alarm also connected to this product, and that there is an event which might be sent to the telephone lines. So to the external entity alarm, I want to tell the alarm that, okay, if the alarm has multiple options, for example, if somebody breaks in, then you want to sound a different alarm. If it's a fire, you want to sound a different alarm. So you are telling to the alarm that depending on certain input from certain sensor, you're saying, okay, depending on this input and depending on what you said here, send an alarm and also trigger a telephone line as well. So these are this is what we do at the context DFD when we're making a level 0 DFD, that we identify all the entities. We say, okay, how these entities are going to talk to my system. So okay, we say there are certain inputs and there are certain outputs. So we have identified that there are basically 2 inputs to my system, and then there are 3 outputs from this level 0 DFD. So we discussed that in our previous lecture, and we were discussing this level 1 DFD. So this is again a decomposition of the same DFD that we have seen. So this is the level 1 DFD of the safe home software. So this is level 1 DFD of the safe home software. Okay. Now we can see that, as I said earlier as well, that an interesting thing about these DFDs, or a level 1 DFD, is that this is the only level of a DFD where we can have all kind of concepts which can be drawn in a DFD. So for example, you can see that in this level we have these external entities, we have data flows, we have processes, we have this data source. So we have all the things that can be drawn in a DFD. They are there in this level 1 DFD. Now it is important to imagine that as an analyst, I knew about some of these things which are drawn in a level 1, but the others are actually your interpretation of how certain transformations would be made. So for example, as an analyst, I knew this, I came to know about the entities. I read those requirements that were written in the form of text, or I listened to those interviews, and I said, okay, these are the entities and these are the inputs. I also know about some of the processes. For example, I know that whenever a user sends something to the system, it's an interaction of the user. So user is interacting with the system. Now, one thing that I might have picked when I read those elicited requirements is that user can send multiple kind of input to my system. So what user can do, user can either supply his password, or the first thing that the user would do, he needs to enter his password. So that is one kind of an input that the user can send. And other kind of input that the user can send is any configuration changes. For example, you want this product to be activated, or you want it to actively take input from all the sensors at 8 p.m. and stop doing that at 7 a.m. whatever. So you can change your configuration settings as well, which may include your master password and all these kind of things. And similarly, you can also tell this device to start or stop when you desire. Okay. So we know that user is interacting with the system. We already know that because we identified that one of the external entities, which is the control panel, and through the control panel the user is sending different kinds of commands and data to my software. But the next thing what I do is I try to identify, okay, what are the possible kind of inputs that the user is sending to my system. So what I do is I make a process and I name it interact with the user. And I number this process 1. I say that this is process 1 of the system, which is interact with the user. And what are the outputs from this process is that kind of the input. For example, this process, what this process is actually doing now, and when I say that we understand the behavior of a process is, so for example, imagine that these DFDs, they are supplied to the software developers or the software engineers, and what they would do then is that they would have to implement it. So when we give them this kind of representations, okay, so they would straight away know, okay, when I am writing this particular process or writing this function, I need to actually understand that what is the kind of input that is being sent to me. So what this process is actually doing is that it is understanding that what kind of input is and producing 3 possible outputs. So either the input is a password, or it's a start-stop request, or it's a change in any configuration settings. So these 3 are the outputs from this process. And now because these outputs or these data are thrown out of this particular process, we need some processes to actually look after these outputs. So we know that, you know, because there's a password floating around, we need a process to actually ensure that whether the supplied password is correct or not. So we need another process, and we name it process password, which what this process is actually doing is it's just actually ensuring that the entered PIN number is or the password is correct or not. So we say, okay, there is another process which is actually processing the password. Similarly, we need a process to look at the start-stop request, and we say this is activate/deactivate system. If the request is start, we activate the system. If it's a stop, we deactivate the system. So this process, depending on what kind of input is being sent to this process, it produces a certain, it actually processes that. So we say, okay, we need another process. And similarly, if the input from the user was change in configuration settings, we need a process to take care of that. So we say, okay, there is a process which configures the system, which actually handles that particular input. Now what are the outputs from these processes? Now one thing that we need to know, that when a user is sending certain input, he would want to see something, okay, and we treated that particular thing as control panel display as an external entity. Now another way that this DFT could have been drawn is that we could have said that, for example, going back to our level 1, we could have said that, you know, control panel is an entity and there is an input coming from this, and instead of drawing this particular bit, we could have said that there is an output going to this external entity, and that is the display information. And then this would have deployed, this would have meant that control panel has a display as well, okay. But we explicitly said that control panel display, we treated control panel display as another external entity, but we could have merged them together as well. So this would have been another way of drawing it. Now we know that user has sent some input, which is he has interacted with the system, he or she, and they would expect certain kind of output. So all these processes, the process that processes the password, the activate and deactivate process, or the configure system process, they are producing certain outputs then. So for example, if the password is valid, then a valid ID message is generated, and whether the system request was to activate or deactivate, the activation message was sent. So activation message can be the system activated or system deactivated, it can be any one of these things. And similarly, the configure system, it produces an output which is the configuration data. Now as far as this process number 2 and process number 3 are concerned, their outputs, whatever their messages are, whether it's a valid ID message or activation message, they are sent to this process, which is the display messages and status. So we know that we are showing certain information to the user, and one kind of information is the response from the system for the inputs that user has sent, whereas you might also want to show the users other information based on the inputs from other external entities as well. And in this particular case, they were the sensors. So we need a process to actually understand that what kind of message we need to actually show to our user. So we made this another process which was display message and status. And this process, what it does is it basically takes all the inputs from different processes and decide what kind of output to show to my external entities. And then another thing why we do it is that if we go back and look at this level 0 DFD, then we are not saying that there are multiple outputs going to this control panel display. We are just saying that there is one output going to control panel display. So, and we have merged all the display information, and we are saying that this display information is one thing which is being sent to this control panel display. So we need a process which actually understands that whether it's an input, whether it's an output from a process password process, or whether it's an output from the activate deactivate process, or whether it's an output from the configuration data process. So, and then this display information is sent to this control panel display. Another thing which I skipped earlier was this data store. Now if you look at this data store, then I said that because we are talking about flow of data, and data need to be stored temporarily as well at times, because we want to know that what's happening to the data through my system. Now configuration data is actually stored within the product, because configuration data may include your master password, it includes when to activate, deactivate this system automatically, and what kind of responses to expect, what kind of alarm to sound, what are the telephone numbers you need to call, and all these things, they can be configuration data. So this information need to be stored within the device. So we are saying, okay, there is a data store also involved, which is actually updating this configuration data, whatever user wanted it to be. And then this data store sends this configuration data to this display message and status, and it through control panel display, the user is informed that your configuration data is updated. Now that was all these 5 processes we have talked about from the perspective of one input, and that was control that was coming from the control panel, and the input was user commands and data. Another external entity was sensors, and sensors send some key information to the system, because this system is revolving around the input from the sensors as well, because depending on the input of the sensors, lots of events might be triggered. So the sensor is sending what input to my system? It is sending the sensor status. For that we make another process which is monitor sensors. And as I said earlier, that there are multiple kind of outputs which can be shown to the user, and we looked at few of those, that you want to tell the user that whether your password is updated or not, whether the configuration data is updated or not as well. Similarly, you also want to tell the user that what is the status of different sensors, and you want to display that on the control panel as well. So this monitor sensors process, it has multiple outputs. So one output from this monitor sensor process is showing the sensor information to the user. So we need to send this data to this display message and status process, to process number 5. And then there are 2 other outputs from this process. Depending on the sensor status, you will sound an alarm, and you may activate a telephone line. But you cannot do that unless and until you know the configuration settings of the system. So there are 2 inputs to the system. One is the actual values from different sensors. Then you have configuration input, and on the basis of these 2 inputs, the sensors or monitor sensors process, it basically is producing 3 kind of outputs. One is the sensor information, and the other 2 outputs are to 2 other external entities, which is alarm and telephone line. So this is how we decompose a level 0 DFD into a level 1 DFD. Let's see how we decompose this further, and let's go to a level 2 DFD. And out of all these processes, the one which I think is pretty interesting is this process, which is monitor sensors, because among all the processes, I want to understand that how my system is going to deal with multiple kind of sensors, because there can be lots of different kind of sensors deployed. You can have smoke sensors, you can have motion sensors, different kind of. So all these sensors, different type of sensor, they would send different type of events. And how do I know which type of sensor it is? So what is my system going to do? And this process, it seems to be quite complex, because in total it has 5 inflows and outflows, two inputs, and it has 3 outputs. So what I would do is I would say, okay, I'm going to decompose this process number 6. So this is a level 2 DFD which actually decomposes further the monitor sensors process, or which was process number 6. So what I say is that, and as you can see in this level 2 DFD, that I have drawn these external entities, but even if I don't draw them, it's fine. You do not need to draw all these things in a level 2 DFT. So we can get away if we don't even draw these external entities, and we just show that there are certain inputs coming to these sub processes of process number 6, and there are certain outputs that are being produced. Okay, now if we remember, let's quickly draw this monitor sensor process here. We try to draw this process number 6 here. We said that there were 2 inputs to this process, and it was producing 3 outputs. One input was coming from the sensors, the other was coming from a data store, and so this was coming from an entity, and among the outputs, 2 outputs were going to the external entities. One was going to the alarm and the other was going to telephone line, and one output was going to another process which was display information, display status, and messages and status. So that was my this process number 6 at level 1, and I said that I wanted to know the behavior of this particular process, so I'm going to decompose it further. So now again the same decomposition principle applies which we applied in our previous case, and we started looking at the inputs, and we said, okay, what is this input? So for example, one of the inputs that I have here is coming from the sensors, and so basically I need a process which actually is reading values from the sensors, and on the basis of that reading, it is actually identifying the type of the sensor and the sensor ID. So what I'm going to do is I'm going to make a process, and I will number this as 6.1, which would show that this is a sub process of process number 6, and what this process is doing, it is actually reading the values coming from the sensor. So sensor status, let's say that all the sensors, they generate, when we monitor them, they generate some message, and that message includes the sensor ID and sensor type. So you're saying that there is sensor ID and type, and this is the output that this produces, and this output, the sensor ID and sensor type, is being sent to another process which is assess engage setup. Now we have some values which we have taken from the sensors, which is sensor ID, sensor type, and the value for that particular type of the sensor. Now we need a process to actually interpret that particular value. For example, let's say the smoke sensor gives us the value of 6, for example, or let's say it gives us the value of 60. Now what does this 60 means? We need a process to interpret that, and we need a process to interpret also that what does this 60 means to this house. Okay, is this level of smoke 60 is okay to this house? So we need a process to actually decide that. So we say, okay, we have taken information, we have read those sensors, we have identified what's the type of the sensor, ID of the sensor. Now we want to know what to do with this particular output. So we make another process and we name it 6.2. We say assess engage setup. Now what this means is that user has set up his system in a certain fashion, and that certain fashion is basically his configuration settings. So this process would take the other input which was coming to this process number 6, and that was coming from the data store, which is the configuration data. So whatever the sensor values are, they are compared against those configuration data, and then based on what kind of action should be taken, if that values, for example, if the smoke sensor value exceeds the acceptable limit and you sense a lot of smoke in the house, what you do is you send some data, because you want to trigger an alarm now. So you will send some, you need to send an output to that external entity alarm. So what you do is you generate an alarm data. Similarly, you generate a telephone number, and you also generate that which sensor has actually generated this information and what is the location of that sensor. Because if it's a big building we are talking about, and if a big house and it has lots of different rooms, we want to know where various smoke is actually coming from, because when the fire brigade comes in, they actually look at this particular display and they say, okay, this is the room where we need to go to and deal with the issue. So there are three outputs which are being produced from this process, which is assess against setup, and these outputs are alarm data, telephone number, and sensor ID type, and also its location. So, and we need that, so when there are three different kind of outputs, we need three processes to actually deal with that, because we know that in the alarm there are multiple alarms are stored. So, for example, if the alarm was generic and there was not an option of multiple alarms, then alarm data was useless, and all we needed to do was just to sound the alarm. And in that case, what we should have done, we should have just sent an output to this external entity alarm. But because we are not doing it, because we have said that alarm, there can be multiple alarms. For example, we want to sound a different alarm if it's a fire, and we want to sound a different alarm if somebody is breaking in. So what we do is that we say we make another process and we name it 6.3, we number it 6.3, and we name it generate alarm signal. And depending on the alarm data, that if the alarm is for smoke, then sound the alarm which sound the fire alarm. If the alarm data represent that there is a motion, there is somebody has broken in, you sound a different kind of alarm. So depending on the alarm data, you generate an output which is the alarm type, and the external entity recognizes that, okay, this is the alarm type I need to sound, and it sounds that particular type of the alarm. And similarly, same you would do with these telephone lines, that a telephone number is being output, and you need a process to actually dial that particular telephone number. So you say, okay, we make number this another process 6.4, and you are dialing the phone, and so this output is being sent to this external entity telephone line. And similarly, the display information which assess against setup process generated, 6.2 process generated, which was the sensor type, sensor ID type and location, you need a process to actually format it, because all the outputs which are being displayed on the control panel display, they need to be of a certain format. So we need a process to actually to format that information, and we say, okay, make another process 6.5, and we put that information in a certain desirable format. For example, we want to show to the user that it was sensor ID number 66 and location was bedroom or first floor, something like it. So this is kind of the information that we want to show to the user. So we format it in a certain fashion, and we send that output to our main process, which was displaying output to the which was dealing with multiple kind of outputs which are being displayed on the control panel, and that process was this display message and status. So we send this to process number 5. Okay, now as I said that because this is a level 2 DFD, so we do not need to draw these external entities, these external processes. We are fine even if we show that these are the inputs and these are the outputs which are going out from the this level 2 DFD. But we should be what we should be concerned about is that whether this DFD is balanced or not, because we said this is very important that your DFDs are balanced. And so we counted the number of inputs and outputs to this particular process number 6. We said that there are 2 inputs and then there are 3 outputs. And so let's see if this DFD is balanced or not. So this is the boundary, this dashed or this broken oval around this these sub-processes. They actually indicate the boundary of process number 6. So this is the boundary of process number 6. So what I can count here that there are 2 inputs or 2 inflows to the sub-processes of process number 6, and then there are 3 outputs, 1, 2, and 3. So I can safely say, okay, that this DFD is balanced. So this is fine. So that is how we, as an analyst, we gain an understanding. So you can actually appreciate that, how we came from, where we had just had one process. We just said, okay, this is my system, and these are the people who are sending inputs, and these are the systems who are expecting output from my system. And you came to this level where you have broken down and you have understood your behavior of the system. You have broken down to these smaller sub-processes, and okay, how this input data is transformed into this, smaller input data, and what is the interpretation of this data to my system. And once you have drawn all these things, you take it back to the client and say, okay, this is how I think the system is going to behave depending on your information from these multiple sensors. and then all the confusion or all the ambiguities, or if there are any inconsistencies, you can go and talk to the client, and these would be resolved if you have this kind of representation of the system. So DFDs are a very useful tool for understanding and analyzing your initial requirements that you have gathered at the elicitation stage. So let's look at, as I said, that there are other diagram. There is another diagram which we can draw in this flow-oriented modeling, and that was control flow diagram. This control flow diagram, it is an interesting diagram. What we do is that we try to identify the different states of this. So what we do, we can do it for different functions of this safe-home product. Because this whole DFD, or when we are trying to interpret, or when we are trying to understand the behavior of the system, we are trying to do it through these functions. We identify different kind of data, and we say, okay, how my system is going to transform that data, how my system is going to behave based on different kind of inputs. So what we do is we, depending on a function, we draw different states of our device. So what we say here is that for example, my device can be in 4 possible states. Either I would be resetting my device, either my device would be idle, or my device would be acting on an alarm, or my device would be in the monitoring state. So let's say this is the starting state of my system, and I send the information of start and stop. Or let's say there is a button when I turn it on, the device is activated, and then when I turn it off, device is deactivated. So what's happening here is I'm saying that when I press this button, then the entry or the set system status is inactive. What I would do is message 1 is starting system, message 2 is please wait, and display status is it's saying the slow blinking and do run diagnostic. So basically what you're doing here is when the device is being reset, these are the things that the device is going to do. Initially we say the device is inactive, then a message is displayed that okay, the system is starting, and then there is a message saying please wait, and the light is blinking, and then we are checking the system whether the system is fine, whether it can actually read the configuration data, and then the system is reset. If this is successful, and if the system diagnostic they run fine, we move from this resetting state to this idle state. Okay. If it fails, then we come here and we contact the vendor, okay, that the system is not starting up or it is not resetting, and this whole state or this whole control flow diagram, the flow actually ends here. But if the system is okay, then the control is here now. Okay. And we know that when the system is idle, we know that system is inactive, it is ready, and it is also steady. Okay. Now if there is a problem here with the system, we can go back here and we can say okay, reset the system again, and we do the same thing that we did earlier with the resetting. We press this button and to reset the button, and if the resetting goes okay, we come back to this idle state. Otherwise, if the resetting failed, then we go and contact the vendor, because the fail message is being displayed on the control panel display. Now when the device is idle and it has actually started, and so what I can do here is that either I can activate my device or I can shut it down. Okay. When I'm activating my device, I'm actually supplying it my password, and I'm saying okay, and now when I activate this, it is in this state, which is the monitoring system state. So the display information which is being displayed is monitoring, armed, and the system is steady. Okay, the system is activated now, and so this is another state of this particular function, which is security, the safe home security function. Okay, that how this security function is actually going about. But when I can also send, when I am actually in the monitoring state, there are multiple things that I can do. I can trigger certain kind of alarms based on different input from different sensors. So this is that output, and another output from this state is this deactivate password. So that is another control flow information. If I deactivate it, I go back to the idle state. If I sense certain sensor and a certain control information is triggered, then I go into this acting on alarm state. Okay. and I would display that my status is monitor and alarm, and an alarm is being triggered, and I also display the information of the triggering sensors, and I also sound the alarm, and I do lots of these things. So these actions which are due here, these are the things which are done at this particular state. So what I do is I monitor and control the system, I sound the alarm, I notify alarm responders. So this is based on this particular input. But if this control information is sent, I go back to this idle state. So when I am in this state acting on alarm, either I will deactivate the password, I will go back to this idle state. If it's a false alarm, I go back to the monitoring state. If timeouts, I go back to the monitoring state. So this is an other way of showing that what if we want to further understand behavior of one particular function in the system, we can draw control flow diagrams for it. So for example, we want you to know that how the safe home security function is going to work in terms of the whole product. Okay, so we know that this device can be in 4 possible states depending on different kind of information which is being which this device interprets. So for example, we say that device, either we can reset the device, either the device would be idle, or it can be activated and it is actually waiting for some event to occur, and it is in the monitoring state, and another state would be it is acting on the alarm. Okay. So we want to know, okay, that how this security home function would jump from one state to the other state based on what kind of control information. And we said that, you know, when the device is in the idle state, and if you activate the device, it will jump from the idle state based on the certain control for information. It will jump from this state to the monitoring state, and so on and so forth. So this is another way of understanding the behavior of one particular function. If you want to know that how this function is actually dealing with the whole, in terms of the whole product, then you can also draw these control flow diagrams. Then the final tool that we can use in this structured approach of analysis is the processing narratives. And this is the same text that we have seen so often now, and we are saying that, you know, what we do is that this is actually recommended that you start this flow-oriented modeling, or you start this structured analysis through these processing narratives. Is that what we try to do is we try to identify that in the textual format, we try to identify that what are the main key functions which are being applied on different kind of input. So what we do is, if we read the first paragraph, then it says the safe home security function enables the homeowner to configure the security system. When it is installed, monitor all the sensors connected to the security system, and interacts with the homeowner through the internet, a PC, or a control panel. So as we remember that, you know, when we are drawing this level 0, level 1, level 2 DFDs, what we are interested in nouns, we are interested in action verbs, and we are also interested in all the noun clauses. So it is just we transform this particular line and we try to identify, you know, what are the action words and what are the nouns. So what we are doing here again is something similar that we did earlier as well when we did the grammatical part. So what we do is we go through this particular statement and we try to identify all the action words and all the nouns. So what we do is here that we say, okay, the safe home security function, it enables the homeowner. So we know that, you know, the homeowner is an entity, but whether we want to show it as an entity or not, we will decide later. It is configuring the system. So we know that one function or one process would be there which actually takes the configuration input from the homeowner, and one kind of input that would be sent to this particular device is the configuration input. When it is installed, and we know our system is going to monitor the sensors. So we know, okay, there is this action word which is monitors, and we identified another entity which is the sensors. And interacts with the homeowner through the internet, a PC, or a control panel. So we are deciding that control panel, this user or the homeowner. So we say, okay, homeowner is not the external entity, but this control panel is, because this statement actually says that homeowner would be interacting with the system with either internet, PC, or a control panel. So we are saying, okay, if it's control panel, then we have identified 2 external entities, which is the control panel and it's the sensor. So during installation, the safe home PC is used to program and configure the system. So initially, the system is configured using the safe home PC, and we know that, you know, and we've already identified that configuration data is one kind of input. Each sensor is assigned a number and a type. So we know, okay, that our process which we identified, which said that monitor all sensors, when it is monitoring a sensor, it is also going to get information from the sensor that what is the sensor number and what is the type of that sensor. So we identified some other data, which is number and type. And then we are saying a master password is programmed for arming and disarming the system. So we know that there is another data, which is the master password, which may be sent to activate or deactivate my system, and which would be sent by the user. So this is another information, another data which is being sent, or which my system had to actually take care of. And then I know that telephone numbers are input for dialing when a sensor event occurs. So I know that I have identified this monitor sensor process, and I've identified some kind of sensor data. I've said that each sensor has a type and an ID. I also know that depending on the values of the sensor, those certain telephone numbers which I have stored, they would be dialed. So I need a process for dialing as well, for dialing particular telephone numbers. When a sensor event is recognized, the software invokes an audible alarm. So I know that there is another trigger, which is my software is going to invoke. So invoke an audible alarm. So there is some kind of alarm data attached to the system. So I know another external entity which I have identified is alarm. After a delay time that is specified by the homeowner during system configuration activities, the software dials a telephone number of a monitoring service. So I know that there is a monitoring service to which my system is going to dial, and provides information about the location, reporting the nature of the event that has been detected. The telephone number will be redialed every 20 seconds until a telephone connection is obtained. And this is what you would have seen in this diagram as well, that there was a timer here as well. So when the system was acting on alarm, then the system, another action that system is going to do is going to dial again and again. And you dial, you wait, for example, you dial, you wait 20 seconds and the connection is not established, you redial again until a connection is being made. So all these processing narratives, what we are doing through these processing narratives is because as an analyst, this is what we have. So we have text written in front of you. We have the description of the system written in form of natural language in front of us, and we need to understand, we need to identify external entities, we need to identify these processes, we need to identify all those data flows, we need to, all the types of data that my system is dealing with, I need to identify. So processing narratives is a very useful tool when we are doing this structured analysis in this elaboration process. So that is it, what we are going to cover in today's lecture, and let's quickly recap what we have done so far within this requirement engineering process perspective, and specifically what we are going to recap is what we have done today. So this is so we started our lecture today with a brief overview and of DFDs, and we finished our example of DFD. We also looked at control flow diagrams. We also looked at processing narratives, and just to give a perspective at that where we are at the moment, we said that requirement engineering process consists of multiple tasks, and we said that the first one was inception, the second one was elicitation, and then the third one was elaboration, and there were a few more as well. So, but later we said that these are not just tasks; they are also processes. Why they are processes? Because they are doing something to achieve a certain goal, and in order to do that, there are certain subtasks, or there are certain activities involved in these processes. So we looked at inception. We said how the inception process is conducted. Then we looked at elicitation, that how this elicitation process is conducted, what are the different steps involved in it, what are the different techniques of elicitation. And we said that one of the outputs, or the outputs that we get from elicitation, is written text about the system, and that can be very raw, and because we have gathered it through multiple techniques, because we might have some data which we have taken through interviews, we might have conducted some survey, we might have conducted some brainstorming sessions, and we have some disjoint kind of text. So what we want to do now is we want to analyze it further, because that is the job of system analyst, because we want to know that whatever we have gathered, that is consistent, it's complete, and it's not ambiguous. So that is for that purpose we do elaboration, or we do analysis of the elicited requirements. And in analysis we said that analysis can be done in two possible ways, or there are two different approaches of analyzing requirements. One was object-oriented approach and the other one was structured approach. And within object-oriented approach we said there are multiple kind of modeling can be done. There is scenario-based modeling, there is class modeling, there is behavioral modeling. And within the structured approach we said we can do flow-based modeling or flow-oriented modeling. And within flow modeling we talked about three different tools or diagrams that we can make. Number one, we talked about DFDs, data flow diagrams, and we said when we are modeling DFDs, what we are interested in, we want to know what is the flow of data through my system, and when this data is flowing through my system, what transformations are applied on it, and by identifying those transformations I understand the behavior of my system. Then we also said that there is another diagram which is control flow diagram, and there is a function which is key to my system, and I want to know that how my system behaves and what is how the behavior of my system is going to change in terms of that function based on different inputs. So what we do in a control flow diagram, we identify different control inputs or control outputs from these different states, and we looked at an example of this safe home security function where we said that our system can be in resetting, idle, acting on alarm, or a monitoring state, and based on different control information we saw that system is jumping from between different states. And finally we looked at processing narratives, and we said that this is a very useful tool when we start this structured approach or when we do this flow oriented modeling, because when we express the text in form of processing narratives, we are able to identify all the nouns, noun clauses, and all the verbs, and through that we identify processes, data flows, and the external entities. So we have looked at the structured approach today. We have finished our discussion on flow-based modeling, and we have also concluded our discussion on the elaboration process or the analysis process. And in the next lecture, what I would try to do, I would try to put all these things in perspective in terms of requirement engineering process, that as an analyst, what do we have at this stage? As far as today's lecture is concerned, I think that is about it, and inshallah I will see you in our next lecture. Take care, and Allah Hafiz.